have discussed you what is an ideal solution and what are the conditions for a solution to behave like an ideal. Then I told you what type of molecules will show or will make ideal solutions. Then then after that I told you what is a non-ideal solution. A non-ideal solution is the one which does not obey Raoult's law, and moreover, the volume obtained after mixing of the solute and solvent, it is not exactly equal to the sum of the volumes of the solute and solvent. It may be either more or less, and the heat involved in the process or heat change in the process, we find it is not zero. It may be either more means positive, or it may be less than zero, it may be negative. So on the basis of that, we find that we can classify non-ideal solutions into two categories. These are non-ideal solutions with positive deviations from Raoult's law and non-ideal solutions with negative deviations from Raoult's law. So that day I have discussed in detail the non-ideal solutions showing positive deviation from Raoult's law, and by the way the time was over, means I did not continue with it because it will be very long process. So today I'm going to discuss non-ideal solutions showing negative deviation from Raoult's law. Okay. So let's see. In the solution, the vapor pressure of the solution is less than the sum of the partial vapor pressure of P is less than A plus P. Why? Because the partial vapor pressure of individual components are less than the product of vapor pressure of pure components and their mole fraction. That is, TA is less than IA and EB is less than B0 I. Or what we can write? Therefore, P is less than, let me put it here, A0 IA
Done, sir.
second. Of the solution is less than, that is, delta is mix is less than 0. Why? The enthalpy change the solution is less than 0. That is, delta is less than 0, or that is, it is going to, the process will be, this case what? because it's going to liberate heat. The solution, in case of solution, heat will be liberated.
Done, sir.
So try to understand. This thing that you will not be able to feel it, but this you can feel. It is, again, I'm telling you, suppose you have taken 70 ml of the solvent and 30 ml of the solute. When you mix it, in ideal solution should be 100 ml. And with positive division is found that it is more than 100. But in this case, we'll find total will not be 100 ml, it will be less than 100 ml. So it is less than 0 or negative. When you mix them, in that case, you will find the solution will get warm. Without heating, it will become warm. Right? That is, the enthalpy change is negative. Clear? So you will find that this is going to be exothermic. Now we should know why it is happening. Why? The solution in which the solute solvent interactions means what? When the solute solvent interactions will come. Okay? When you will find this is the last step. It is the final step. Okay. Interactions. What should I write here? By convention, I told you, by your book, A is considered to be solvent and B is solute. Are stronger than the solute that is B and solvent A. So when the solute start loving the solvent, in that case you will find that they are going to form this type of solutions. All right. So now, yes, their interactions are stronger. So solute and solvent molecule will come closer to each other. Due to stronger solute solvent interaction means what? Attraction. The solute and solvent molecules come closer to each other. Solute molecules come closer to each other. That in that case, what will happen? Decreasing their intermolecular distances. Decreasing their intermolecular distances, leading to contraction in volume. Volume decreases. Because of stronger affinity and solvent molecules. Because see, as the system becomes stable, is going to release it. Molecules. The solution releases heat or delta H mix is less than 0 or
Done, sir.
very good, very good. So now we'll see examples.
So what is the meaning of affinity?
Huh?
So
Hello?
what is the meaning of affinity?
Affinity means liking. Suppose you love a food, you can say, I have great affinity for this food. Okay. Examples. Examples of non-ideal solutions with negative deviations from Raoult's acetone diethyl ether.
Sir, number 6.
Oh, 1, 2, 3, 4, 5, 6. Sorry, dear. Sorry.
Done, sir.
Okay. Now I'll show you the graph. See, this is for the ideal. See, it is not necessarily that PA you should go always left. You can write ulta also. PA can be like this, PP also can be like more friction. Okay. Now, that's because it decreases now. What should I write now here? PA is less than and this is PA is less than this is PB is less than PB0. So this is for no. Now we'll do one example. I'll write down question. What type of solution is chloroform, acetone. So I'll explain everything to you. See, chloroform. What type of interaction chloroform molecule has within them? See, you are not babies, huh? You should know everything. See, between carbon and chlorine, which is more electronegative? I don't go into hibernation moment I ask you question. Between carbon,
chlorine.
yes. So chlorine is going to put electron. It will make this carbon highly electron deficient. See, this pore flow then from whom will borrow? This carbon cannot take chlorine electron from neighboring chlorine because he is also pulling. This is also pulling. So carbon has no other alternative to pull the electron from hydrogen. Okay. So now see here, you know how to show polar molecule. Look at this hydrogen fellow. So it is a dipolar molecule. So what will happen? You know, they are going to show you dipole. In your exam, you don't have to write it. Your teacher may not write. But if my student writes, I'll be very happy. Because science is not a subject to by heart. It is a subject of logic. So what type of interaction it has? Dipole interactions. Okay. It is having dipole. Oh, now we'll go for acetone. Okay, acetone don't become nervous, huh? See, now the case is ulta. Oxygen is more electronegative than carbon. So, and pi bonds are very easy to break. It will be del minus, del plus. So this is also a polar molecule. So it will be like this. So this is also having dipole. Okay. So I have added. You can pour chloroform in acetone or you can put acetone into chloroform. It's up to you. Now I'll write here now. Chloroform. Acetone. Mixture. See, this hydrogen become extremely electron deficient. This poor fellow, and he cannot take electron from anyone else. Others are so selfish. So what is going to happen? See here. Moment you mix them, look, this oxygen is having now. Oxygen is already having 2 lone pairs, and moreover, it pulls electron from the carbon. Now it is oxygen is electron rich. And look at this helpless fellow. This is like this. Now it has got a very good neighbor who can help them with electronic forms. Hydrogen bond. Hydrogen bond is the strongest intermolecular attractions. Okay. Okay. You have seen these interactions were dipole-dipole interaction is a weak interaction. Weakest is dispersion force. Then come dipole-dipole interaction. So there were some gaps were there within the molecule. Moment you mix them, because of hydrogen bond, it has come very close. So when they have come close, what will happen? The intermolecular distances between them will decrease. So there will be shortfall in the volume. 30 plus 70 will not be now 100. It will be less than 100 ml. Okay. And see, now this molecule has become, this molecule after forming the hydrogen bond, both of them has become highly stable. Okay. So in that case, the present interactions are interactions or attractions has become stronger than the previous one. So the solution is going to liberate it. So we can say that acetate chloroform mixture is a non-ideal solution with negative deviation. You should be able to write it. And for you people, so you have studied English right from KG, so you should be able to write better English than me. Okay, my English is not that good. Anyway, I'll try to write it. Somewhere I make mistake, please correct. We'll write now here. In acetone chloroform mixture. The solute solvent is A plus B. Interaction is stronger than previous solute B, and solvent A in, you need not write all hydrogen bonding and all this thing, huh? You show there are interactions. And when in exam, you don't have to show the chloroform and the acetone structures. Only show the final one. Okay. So what we'll write now? English is so poor, even spelling also I'm making mistake. Due to stronger intermolecular forces of attraction between solute and solvent. The gap between the molecules decreases, resulting contraction in volume. That is delta V mix is less than 0 or negative. Because of stronger traction between the solute and solvent molecules.
Excuse me, sir. After that is, what is that, sir?
That is delta V mix.
The
Oh,
B is not there, no, sir.
correct. Very good point. Delta V mix. Huh? Because of stronger attraction between the solute and solvent molecules, the solution releases heat. That is delta H mix is less than 0. Hence, acetone, chloroform mixture is a non-ideal solution with negative deviation from Raoult's law. Acha, this all these things that I'm writing, and I have given you the note also. Are you reading? Are you reading at home? Hello? Huh? Topic known as agiotrope. 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 Then let me ask first, take the help from Gitanjali only. Gitanjali, what is this meaning of agiotrope?
Sir, we didn't do this in school. Is your true?
तू बहुत चालाक है सुजुरी.
No, sir, we did have.
Huh? What is the definition of boiling point? Any idea what is called boiling point? Hey, till now you don't know what is called boiling point. Class 11 you have studied now. Hey, boiling. I don't feel like
Sir,
scolding.
the temperature in which the liquid boils.
Huh?
The temperature in which the liquid boils.
No, I don't want dictionary meaning. The temperature at which vapor pressure of the solution becomes equal to the atmospheric pressure. That is called boiling point. Okay. See here, there are some mixture. See, if you have taken two liquids, say A and B, boiling point of this one is 100 and this is 70. We know we can separate two liquids by fractional distillation. So when you heat them, the vapor of A and vapor of B, both of the vapor come. Okay. As the boiling point of this one is less, so it generates more vapor. And here it generates less vapor. So when this becomes equal to atmospheric pressure, you will find this one will distill out and this will remain in the flask. Because this vapor when goes, it's as because it's 100 degree and this is 70 degree, the condenser will have a temperature of 70 degree. So but 70 degree is far less than 100 degree. So this vapor will condense and it will fall down. It will get again converted into liquid. So this B will come out. When all the B has come out, then you find again this. Now, in that case, this liquid again will vaporize. Now, in that case, when the vapor pressure of the A is become, when this has come out already, when the vapor pressure of this one, when you generate enough vapor, when it becomes 760 millimeter of mercury, then it will come out. So this is the way by which we separate two liquid from a mixture. This is called fractional distillation. But we find there are some mixtures. Okay, say it is A and B. It is 70:30. Now I'm not writing here the boiling point. This is the ratio. So this is the liquid state. When it vaporizes, we'll find this is also in the ratio of 70:30. So in this case, you cannot separate this mixture. It will get condensed, and again it will give you a mixture which is having 70% of A and 30% of A. So this type of mixtures are called azeotrophs. Excuse me. Hello, আগে শুনি আচ্ছা আচ্ছা তো আমি ক্লাস নিতেছি ওখানে বাইরে যাবো হ্যাঁ আমি 2 মিনিট পরে বাইরে না হুম হুম So the binary mixtures having same composition in liquid as well as in vapor phase. And boil at a constant temperature. So you cannot separate them. Same temperature will boil. Are called azeotropes. In such case, it is not possible to separate the components by fractional distillation. There are two types of azeotropes. Minimum boiling azeotrope and maximum boiling azeotropes. आइतेছে 1 মিনিট minimum boiling azeotrope. Minimum boiling azeotrope. Very easy, huh? Suppose, as I told you, see, boiling point of alcohol is 76 degree and boiling point of water is 100 degree. All of us we know. If you mix them, then they form a azeotrope at a certain percentage. And in that case, you will find this mixture will boil below the boiling point of both the components. Means it is going to boil below 100 degree or and 76 degree. Means what? It is going to boil below 76 degree. So these are called minimum boiling azeotrope. So let us write. These are the mixture of liquids whose boiling point is less than both the components. Now, what type of solution they are going to form? See, both of them, they don't like each other. They want to get rid of each other. So alcohol will think, let me get out of water. Water will think, no, let me get out of alcohol. So in that case, what is going to happen? They will boil below 76 degrees. That is, what type of solutions are there? They are non-ideal solutions. Who does not like each other? It is the positive deviation. Please remember this one. They are formed by non-ideal solutions showing positive deviation. Okay, now example. Example is 95% ethanol, 5% water. Okay, now we'll go for maximum boiling just opposite the mixture of liquids whose boiling point is more than the more than both the component. They are C. Now, in this case, their boiling point is more. Why? Because they don't like to leave each other. If A wants to go, B requests, no, please don't go. B wants to go, A does not leave him. So these type of solutions are, what do you find? Where the solute solvent interactions are stronger? Negative deviation. They are formed by non-ideal solutions showing negative deviation. Example, 20.2% HCl and 79.8% water.